Welcome to Daily Papers, the podcast where we break down the latest and most exciting research into bite-sized pieces. Today, we're talking about something that sounds like it's straight out of science fiction. Imagine an AI that doesn't just write code, but discovers fundamentally new and better ways to solve problems, breaking records that have stood for over half a century.
It's a reality. We're diving into a new paper from Google DeepMind called AlphaEvolve, a coding agent for scientific and algorithmic discovery. The headline is that this AI has created new world-class computer algorithms from scratch.
So how does it work? Let's use an analogy. Imagine you have a recipe for a chocolate cake. It's a pretty good recipe, but you think it could be better. You could spend weeks trying different amounts of sugar, different baking times, new ingredients. It would take forever.
Right, but what if you had an expert chef who could suggest changes and a robot that could instantly bake and taste test each new version?
Exactly. That's basically AlphaEvolve. But instead of cake recipes, it's working with computer algorithms. An algorithm is just a set of instructions, like a recipe, that tells a computer how to do something.
So a programmer gives AlphaEvolve a starting algorithm, but how does it come up with the new ingredients or different baking times?
It uses what's called a large language model, or LLM. You've probably heard of AI like ChatGPT. That's an LLM. These are AI systems trained on vast amounts of text and code from the internet. They're really good at understanding patterns and generating new creative ideas. In this case, AlphaEvolve's LLM suggests changes to the algorithm's code.
Okay, so the LLM suggests a new version of the code, but how does it know if it's any good? Who does the taste testing?
That's the other crucial part. The human programmer also provides an evaluator. This is a program that automatically runs the new algorithm and gives it a score. Is it faster? Is it more efficient? Is it more accurate? This all happens automatically thousands upon thousands of times.
And this is where the evolve part of AlphaEvolve comes in, right? It's an evolutionary approach.
Precisely. It's like survival of the fittest, but for code. The system generates lots of new offspring algorithms. The ones that get a high score from the evaluator survive and are added to a collection of good solutions. These successful algorithms are then shown back to the LLM as inspiration for the next generation of ideas.
So over many generations, the algorithms literally evolve to become better and better. That is an incredibly cool concept. But does it actually work? What did it discover?
Oh, it works. Let's talk about the headline result, which is in a field that sounds a bit dry, but is fundamental to almost everything we do with computers: matrix multiplication.
Okay, break that down for us. What is matrix multiplication and why should we care?
Think of it as a basic but super important mathematical operation. It's used everywhere in the 3D graphics for your favorite video games, in weather forecasting, and especially in training the very AI models we're talking about. Making matrix multiplication even a tiny fraction of a percent faster saves enormous amounts of energy and time across the world.
And for one specific type of matrix multiplication, the best-known algorithm had been around for a very, very long time.
56 years, to be exact. An algorithm by a mathematician named Strassen was the state of the art. No one had found a better way to do it. Until now. AlphaEvolve discovered a new, more efficient algorithm, becoming the first to improve on that record in over half a century.
That's incredible. Just by evolving code, it beat a record that has stood for longer than many of us have been alive. Is it just a one-trick pony, though?
Not at all. The researchers threw it at a whole suite of over 50 unsolved problems in pure mathematics. These are famously difficult abstract problems that mathematicians work on with names like the kissing numbers problem.
The kissing numbers problem? That sounds intriguing.
It's about how many spheres you can have kissing a central sphere without overlapping. The point is, these are hard problems, and in about 20% of the cases, AlphaEvolve discovered new solutions that were better than any previously known, setting new records in multiple areas of mathematics.
So it's a genuine discovery engine for theoretical science. But the paper also talks about some very practical real-world applications right inside Google.
Yes, and this is where it gets really interesting. They applied it to the huge problem of scheduling jobs in Google's data centers. A data center has thousands of computers, and you have millions of tasks like search queries or YouTube video processing that need to run. Assigning these jobs efficiently is a massive logistical puzzle.
It's a bit like a game of Tetris, trying to fit all the jobs onto the available computers without leaving any awkward gaps, or what the paper calls stranded resources.
A perfect analogy. If a computer runs out of memory but still has processing power free, that power is stranded. You can't use it. AlphaEvolve evolved a new scheduling algorithm, a new set of rules for playing this giant game of Tetris that is more efficient. The result? It recovers on average 0.7% of Google's fleet-wide computing resources.
0.7% might not sound like a lot, but at the scale of Google, that's equivalent to thousands and thousands of computers worth of power being saved every single day.
And it gets even more meta. The AI models that AlphaEvolve uses are part of the Gemini family. The researchers turned AlphaEvolve back on itself, using it to optimize the code that is used to train new versions of Gemini.
Wait, so the AI is making itself more efficient? It's optimizing its own creation process?
Yes, it's an AI improvement feedback loop. They also used it to find a way to simplify the circuit design for Google's custom hardware, their tensor processing units, or TPUs. So it's making software, algorithms, and even hardware designs better.
So what's the big takeaway here? Is it that AI is going to solve all of science for us?
Not just yet. The paper is clear about its main limitation. AlphaEvolve needs that automatic evaluator, that judge that can give a score instantly. That works great for math and code, but it can't run a real-world experiment in a biology lab, for instance.
But what it represents is a powerful new tool. It's a way to explore a vast space of possible solutions that would be impossible for a human to check manually. It acts as a partner, a creative collaborator for scientists and engineers.
It shows that we can use AI not just to execute tasks we already know how to do, but to discover genuinely new knowledge and create things that are better than what we as humans have managed to design so far.
From breaking a 56-year-old math record to making global computing infrastructure more efficient, AlphaEvolve shows us a future where AI-powered discovery could accelerate progress in some incredible ways.
A future that's evolving, one line of code at a time.
That's all the time we have for today. Thanks for tuning in to Daily Papers.